Let's start our drought monitoring module. We'll start with script 1A. We're going to work with this data called MODIS vegetation indices. MODIS data is a 250-meter resolution satellite sensor that is about 2 satellites. There is a satellite called Terra in Aqua. Both are capturing images at 250-meter resolution. So it's a coarser resolution data, but since it's coarser resolution, they cover it every day. So you get global image every day. You have a high temporal revisit. Some of the bands of MODIS are 250 meters. MODIS is custom designed for vegetation tracking. So the near infrared red band are 250 meters. Other bands are 500 meters. So if we get the highest resolution NDVI data that's available out of MODIS, this is pre-computed. So instead of taking the raw MODIS data, computing NDVI, you get a direct NDVI as a collection. So this is the data set. You have 2 bands. There's a band of NDVI and there's a band of EVI. EVI is an enhanced vegetation index. It is similar to NDVI, but if you are trying to track changes in vegetation in very dense forest, NDVI saturates. You'll always see value like 1, and it won't go higher than that. So EVI is used where it doesn't saturate. You'll still see differences in a very high vegetation region. But for agriculture, NDVI is better. It is more sensitive to the agriculture. So for agriculture tracking, what we are interested in, we'll use NDVI. This is a 16-day composite. In MODIS, you have daily images, but why 16-day? Because of cloud. MODIS is a very big pixel. So you have 250-meter pixel. Even if there's one cloud within the 250-meter pixel, the entire pixel is contaminated. So even after 16 days, you'll still see that there are many pixels which doesn't have a fully cloud-free observation over 16 days. So this is the minimum kind of compositing period that you do. MODIS team does this. They've described the algorithm. If you want to know how they've done this, you can read this documentation to say how they composited. It's not a median composite. They kind of use a different algorithm to determine what is the best pixel out of the 16 observations, and then they select that. So let's see how this data looks, and we'll work with this data. So we'll import the MODIS data, and we'll define a period. MODIS data is available from year 2000 to current. So we can do this kind of vegetation tracking for any period of time. When we are doing this implementation, we define a start year and end year. If we're doing this for current, we'll do up to 2023. MODIS data is available a few days after the 16-day period is over. So right now you'll have data for like, first half of January will be available. So if in February, you can do up to Jan 2024. But right now we can do it to 2010 to 2023. You need at least 10 years of historic average. You can also do 2000 to 2023. Depends on what you need. The VCI formula states that you need at least 10 years of observations for it to be valid. So for now, let's just assume that we are in 2020. You can change this date later on for the current year, and we'll kind of see this 10-year data, and we'll see how to compute that. So let's work with MODIS data. We'll first apply a filter. We take the MODIS, apply filters, and say filter, EE filter date. And we'll say we need to create the start and end date. So we'll first create the start date. As you know, from now on, we'll use the alternate API to create the start and end date. So we say start year 1/1 is the start date. My end date is end year +1. Right? So, and we'll do start date and end date. These are global images, so you don't need to apply a bounds filter, because just you get each image is a global NDVI image for the entire world. Let's print this and see what we get. So you get collection with 253 images, and you can see this is an image was collected. Start date is 1st Jan 2010, 17th Jan 2010, 2nd Feb 2010, and so on. Right? Every 16 days you get one image. Each image has multiple bands. You have an NDVI band, you have EVI band, you have some pixel values, you have some QA values, and so on. We don't need all of this. All we need is this NDVI band. So I'm just going to select the NDVI band. NDVI values are, again, you need to apply a scale. They're not true NDVI values, because NDVI is a floating point number. You don't know, providers do not want to give you images with floating point number because it takes more storage. So the pixel values are integer values. To get NDVI, you need to look at the scale. So if you look at the dataset documentation, you'll see that there's a scale value, 0.0001. So to get the true NDVI, you need to multiply it by this scale factor, and then you'll get values between -1 to +1. Right now, the values are between -2000 to +10,000. So that is the actual pixel values. Scale it by this, and you'll get the values. We'll do the scaling a little later on. But right now, if you want to visualize it, the pixel values will be between, let's say, 0 and 7,000, because NDVI is usually between 0 to 0.7. All right, let's do the exercise.